Assalamualaikum, a very good afternoon to all. So we will continue on the second part in the Fourier series, which is the discrete time Fourier series presentation. And if you look at what you have on the slide, is that this is the equation for the discrete time Fourier series, whereby the equation is almost similar to the continuous time Fourier series. So for, if you remember, okay, if you remember, for this is the discrete time Fourier series, and then we have here the continuous time Fourier series. So for the continuous time Fourier series, the equation is given by, what was it? Minus infinity into infinity. So ak ejk omega e. Okay, so whereby omega, as you know, omega is equal to 2 pi e, right? So you have here summation of minus infinity into infinity ak ejk 2 pi over t e. Right. So it looks almost similar lah, just that the difference is, of course, what is the difference? This difference is that you have the square bracket over here, and this is you have the normal bracket. And also the another difference is that you have the n value, and here you have the t value. So that's the difference. Okay. So and for the Fourier series coefficient, so from this slide is that this is the equation for xn. Okay, xn. So how about for the Fourier series coefficient? So if you see for the discrete time Fourier series, the value for ak, this is for the discrete time Fourier series, ak is equivalent to 1 over n, the summation of xn e minus jk omega n. So there is actually a difference which is in this symbol. So if you remember, what was the for the continuous time Fourier series, the equation is that ak equal to 1 over, what was it? 1 over t, okay, integration of 0 to t xt e minus jk omega t. So what's the difference? The difference is in terms of this one. This is summation and this is integration. Okay, so if you see the definition that is given here is that as usual, a naught is the constant value, which is known as the DC term. Okay, a1 it will be known as the fundamental component, a2 will be the second harmonic, and so on. But okay, so since for the equation of discrete time is that ak is equivalent to 1 over n summation of xt, so it's actually not a infinite value, so it actually a finite value. Finite value means that for discrete time it's infinity, so it's from minus infinity to infinity. But for the discrete time is that in terms of the k value, okay, it's going to repeat again for the n harmonic component. So let's look at, I will discuss it later in an example. What does it mean? Okay, so how do you actually find the coefficient? So similarly what you have done in the continuous time, so determine what is the period t, and then find the fundamental frequency omega 2 pi over n, and then finally evaluate the Fourier coefficient. Okay, so so this one will be the first equation that you need to remember for the discrete time Fourier series. And after you calculate for the ak value, then you're going to plot for the magnitude and also the phase value. Okay. So in contrast to the continuous time, so there is one big difference between the discrete time and continuous time Fourier series, is that the Fourier series representation of the discrete time period signal is a finite series with n term. So n term, what is it by n term? Means that for every n term, every n value, okay, this is a value, for example n is equal to 10, n equal to 5, okay, the AK will repeat periodically with period n. Yep. So explanation may be not clear, but I will explain it in an example. So let's look at the first example, example number 1. Okay. So example number 1 is, let me just screenshot that. Example number 1 is, you have a signal, okay, xn equal to sine omega n, and then it's given by the fundamental period n equal to 5. Okay, so omega as normal is equivalent to this value 2 pi over n. So how you're going to do this is by, as usual, expand it first. So we are going to expand this example. So let's expand it. So the solution, kx n. Okay, let's write first the equation sine omega n. So we are going to use Euler. So what is the Euler for sine omega? Sine omega n. So let's say sine omega n equal to ej omega n 1 over 2 pi. Don't forget that. Okay, minus e minus j omega n. So this is Euler identity. So you expand it, you can write it as 1 over 2j. Okay, e j omega n minus 1 over 2j e minus j omega n. Right? So if you see here, okay, what is this value? So according to the equation, the original equation, okay, original equation is that xn is equivalent to summation of 0 to n ak ej omega n. Okay, omega n. We forgot the k value. E j k omega n. So basically you have a k value here. A k value. Okay, so this is k value. So what is the k for this part? So k is equal to 1. This is k equal to minus 1. So now we can list out what is the coefficient. So from this, therefore, okay, a naught. Do you have any a naught? Fundamental? No, you have 0. A1. Do you have A1? Yes, you have. This is A1. This is A minus 1. So A1 is what? A1 is this value. Okay, A2 is this value. So A1 is 1 over 2j. A minus 1 is minus 1 over 2j. So if you expand it, you have here using your calculator 0.5 minus 90 degree. This is 0.5, okay, 90 degree. So now you can plot it. Okay, plot it. Draw out the axis. So you have 0, 1, minus 1, minus 2, 2. Okay, but don't forget that in the question, what it says is that the fundamental period is n equal to 5. So n is equal to 5. Okay, so let's just I write here until 4, 5, 6, minus 3, minus 4, minus 5, minus 6. Okay, so let's plot based on what you have here. So a naught this is AK. So a naught is 0, a1 is 0.5, a2 is a minus a1 is 0.5. Okay, so this is just the axis. Okay, but by definition, if you look at this definition, okay, for the discrete time is that if we consider more than n equal, so it means that the n value with a period of n, then the value ak is going to be repeat periodically with period n. So having said that is that every n period, this ak value, this n value or ak value will be repeating again. So for n equal to 5. Okay, so let's see for n equal to 5, where is it? So you have 1, 0. So n equal to 5 is that you're going to repeat it every n equal to 5. Okay, so n equal to 5, you have here, this is represent the same as this point, so you have 0. Okay, at 4 you have this part. Okay, let me just change the font color so that it's easier for you to understand. Okay. Let's say that I'm going to use blue for this. Okay, 0.5. Okay, so for the 0 point, okay, is at 0 to 5, and then for at ak value here, ak1 is going to repeat n equal to 5. So if it's going to repeat 5, then we are going to have 1, 2, 3, 4, 5. So it's going to repeat here. Sorry, 0.5. And for the negative value, it's going to repeat in the same way lah. So you have here 1, 2, 3, 4, 5. Same also for the negative part and negative part here. So for n, because it's repeating n value. So if you were to draw it out again, it's going to repeat again at 7, 8, 9, 10. It's going to repeat again at 10. So let's say that I plot here at 11, you have 0.5. Okay, and so this one already repeat to the left side, so this is 0. Okay, and minus 1 is going to repeat to minus 6, 0.5. Okay, the blue color here is going to repeat to the left side, so 1, okay, 0, 1, 2, 3, 4, 5. So every n value 0.5. Okay, same goes to this point. Okay, this is going to repeat to the right side, so 1, 2, 3, 4, 5. So this is the final answer for the magnitude value, plotting. So how about the phase plotting? So similarly, okay, so you draw out the the omega value first. 5, 6, 7, 8, 9, 10, 11. So minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, so at 0 you have 0. Okay, and then at 8 equal to 1 you have minus 90 degree. Okay, at 1 you have minus 90 degree, minus 90. Okay, let's say that I'm going to repeat it to the right side. So if this at 0 point is going to repeat to 5 by 5 and equal to 5, it will be repeating at 5 and also repeating at 10. Okay, same goes to the left side, repeating to the left side at here and also at minus 10. Okay, and for the this for a equal to k equal to 1, so it's going to repeat 5. So 1 2 3 4 5 minus 90 degree, at here minus 90 degree. And for the a minus 1 is 90 degree, so a minus 1 is here, is positive 90 degree. 90 degree is going to repeat the right side, 1 2 3 4 5. Okay, 90 degree. It's going to repeat also again here, 1 2 3 4 5. Same goes to the left side. Okay, 1 2 3 4 5. 90 degree. Okay, and then here is 90 degree. Okay, don't forget you have the minus here, minus 90 degree. Okay, so this will be the final answer for this question for sketch for period n. Alright, so let's look at another example, example 2, whereby you have almost similar solution to example 1. So find the series coefficient whereby you have this value. So xn equivalent to sine 3 2 pi n n. Okay, so let me just screenshot that. Let me just screenshot that. Okay, so if you look at this example, okay, let's say that, okay, you are given by xn equal to sine 3 2 pi over 5 n. So if you rewrite this equation, you actually get xn equivalent to sine 3. This is actually what, 2 pi over n, right? So n is 5. So it's actually equal to omega, 3 omega n. Okay, so when you know that this is the equation that you need to expand, expand using Euler. Okay, so let's do the solution. So solution. Okay, you have xn equivalent to sine 3 omega n. Expand it using Euler. What do you get? You have 1 over 2j. Okay, e j 3 omega n minus e minus j 3 omega n. Okay, expand it, 1 over 2j e j 3 omega n minus 1 over 2j e minus j 3 omega n. So now you get what is the e value when. So what is the k value over here? K value is 3. This is k value is minus 3. Therefore, you can write, therefore, ek, which is the Fourier coefficient, okay, is a0 is 0, a1, a minus 1 is 0, a2, a minus 2 is 0, right? So you only have at a3, so a3 is 1 over 2j, which is 0.5 minus 90 degree, and a minus 3 is 1 over minus 1 over 2j, so you have 0.5 90 degree. Okay, so and for the case of n value, what is the n value just now? What was it given? So the question is that k is going to repeat for ak is going to repeat for every n equal to 5. Okay, so let's plot that wave spectrum. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you write out the negative part here. Okay, just duplicate that. Okay, so this is at AK, the magnitude. This is at the phase AK. Okay, so let's plot for A naught. A naught is the phase value is 0. How about A1? A1 is also 0. A minus 1 is 0. Okay, A3 is you have 0.5. So you have A3 is 0.5. Ini 0, 2.0. A3 you have 0. Oh, sorry. 0.5. A minus 3, 0.5. Okay, and how about the base value? So you have at minus 2 0, minus 1 0, 1 and 2 0. You only have a value at 3. 3 is minus 90. Okay, so minus 90, and you have for minus 3 is 90 degree. I'm going to change this color to red so that it's easy for you to understand. Okay, 0.5. So we haven't finished yet. Okay, remember for the discrete time is that you need to repeat it for every n value if it's given n equal to 5 for this question. So let's say that we start to do a repeating motion for n equal to 5. So for 0, 0 for repeat every 5 is that you have at 5 is 0. Okay, this one repeat 1, you have 6, 7, also 0. Okay, and if you go backward also you have 0, minus 5, 0. Okay, minus 2, minus 6, 0, minus 7, 0. Okay, so let's look at 3 at k equal to 3. K equal to 3 if it's going to repeat by 5, okay, n equal to 5. So what do you get? You get 1, 2, 3, 4, 5. So you are going to repeat at 0.5. Okay, at 8. And also you're going to repeat it backward. Okay, so 1, 2, 3, 4, 5. So here actually you have also a value based on this repeating motion. Okay, and you also repeat it back to the left side. So 1, 2, 3, 4, 5. 0.5. Okay, and for the at minus 3 you are going to do the same thing. So every 5 period, so we do it to the right side first. 1, 2, 3, 4, 5. 0.5. 1, 2, 3, 4, 5. 0.5. And also to the left side. So the left side you have 1, 2, 3, 4, 5. 0.5. And also okay, this will be the answer for the EK value. How about for the magnitude, same thing. Okay, you're going to repeat at 3, 5 to the right side and 5 to the left side. So you're going to start with the right side first. So 1, 2, 3, 4, 5, 90 degree, and to the left side 1, 2, 3, 4, 5, minus 90 degree. Okay, and you can also repeat it to the left side also because it's repeating. Every n equal to 5. So 1, 2, 3, 4, 5. So minus 90 degree. For the positive 90 here at minus 3, Okay, you're going to repeat it to the left side. 1, 2, 3, 4, 5, 90 degree. And going to repeat it to the right side. 1, 2, 3, 4, 5. And also to the right side here. 90 degree. Okay, so this will be the final plotting for AK and AK magnitude and phase for this question. And then you need to sketch it for the space spectrum for n equal to 10. So it's going to repeat every 10 any 10 value. So do this exercise and submit it to Padlet. This one will be the exercise to confirm your attendance. Okay, this one submit it as a group. A group. So group. So I want to see there is a total of, I think there were a total of 16 group. Okay, 16 group need to submit and you will discuss on Thursday. Okay, and last part is the property of continuous time and discrete time. So for this, this is you need to do a self-reading. So please go to the library and refer to this textbook. Okay, so Robert Signal System Analysis. So go to this page chapter 4, page 171 to 1744. So only 4 pages. 4 pages. Read through on the property of continuous time and discrete time. This will be your self-study. Okay, so I think that will be all for chapter 3. So please upload the task after you have done. Okay, the class will be from 8 to 10. Okay, so I think that you can actually revise the video up until like 30 minutes to understand it, or repeat it again 30 minutes. Then after that, please discuss it in a group. Okay, you can do an online meeting. Okay, online meeting, and upload that the online meeting with your screenshot. Means that I want to see everybody switching on their camera. Upload it to Padlet. Okay, I will prepare submission. Okay, one is the screenshot of discussion for this exercise. Okay, screenshot of all the members in the group discussing. So do a selfie or anything with the explanation how you're going to answer this. And then also another post will be on the submission of the exercise to Padlet. Okay, so that will be all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.